Hi there! Welcome to the 12th episode of the Synth project, where we are going to build a Synth together. Now that all the components and cables are connected to the PCB, it is time to start working on the VCO case, from decorating the front panel with the appropriate pictures and labels, and to the installation of the PCB inside the case and the connection of all cables. Once we are done, the whole module will be ready for the final tuning and the installation in the Synth rack, which we will do in the next episode of the series. A lot to go through today, and so let's begin immediately. The decal paper with the drawings and the labels for the front panel of the VCO is already printed and treated from the last episode. Now, before doing anything else, we need to check with a light behind the panel that the pieces we need to get out fit correctly the holes in the panel. We can then start to cut the pieces we need, one at a time, and apply them to the panel. The correct procedure to do so is to submerge the decal in the water and make sure that the whole thing becomes wet. Then you leave the decal into the water for a few more seconds, and in my case I found that an extra 10 seconds were more than enough. If you are not sure, try removing the decal from the water and check if the film slides from the paper. If not, put it back in the water for a few more seconds. Once the film is able to slide, leave about 1 cm or about half an inch for the fellow Americans and lay it on the panel in the approximate position. Keep sliding out the paper while holding in place the film. Once the paper is totally removed, as quickly as possible but without breaking the film, make the final adjustments to align the drawings to the holes in the panel. Last step is to remove the excess water from the top of the film and the panel around the film, doing it very carefully, otherwise the film will move again. The film will stop moving once the glue is dry, and for that it takes a few minutes. Once the first piece of the decal is in place, prepare another piece to put on the panel. When you cut the pieces, try to make round cuts, so the contour of the film will be less noticeable after being applied. And also, when you apply these pieces, try to avoid the air bubbles between the panel and the film. If left there, they will cause the film to easily break apart in those areas once everything has dried out. And also, using a small lamp behind the panel helps a lot in verifying that the elements drawn on the paper correspond exactly with the holes in the panel. I relied a lot on this technique to avoid the wrong alignment of the film with the panel. I also suggest that you first apply the decals on the left side and then move to the right, and from the top to the bottom. Don't try to apply the parts in the center first and then those on the sides, because you will risk to have no space to work for sliding away the paper from the film. See how I am laying down now the center right piece of the decal? This way I will still have space to slide away the paper, pulling it from the bottom of the panel. And you see that I was too rude in drying the water drops and the film moved, and so I had to reposition it. And now the last piece on the bottom right. Again, cut it trying to keep the round edges, and then put it in the water. Leave it there for a while, making sure it is fully wet, and so the glue between the paper and the film can loosen up. Then apply the film to the panel and align it against the holes. In this case, I had to put particular attention to also align the labels on the bottom side with those on the decals that were previously put on the bottom left side of the panel. After waiting about 30 minutes to make sure the water is totally gone and the glue is set, use a thin knife to cut the pieces of film that are covering the holes. Since the components need to be inserted from the back of the panel, you need to make sure that the film is removed from the top of the holes, otherwise the whole film would detach when you push the components from behind. A few more holes to uncover. And finally, the graphics of the whole panel is completed. However, before doing anything else, the decals and the whole front panel need to be sprayed with at least 3 thin layers of transparent glossy paint. which will protect the decals from being scratched away while working on the module assembly and later when using the module in the synth rack. Pay attention especially at the first layer of the paint. If you spray too much of it, the film with the panel graphics will melt. The second and the third layers of the paint need also to be thin, but not as thin as the first layer. Since this case is going to hold a PCB handling audio signals, it is important to apply some copper tape to shield the area underneath the PCB, as well as the back of the front panel itself. It doesn't matter that the tape is perfectly flat. You can see that in my case I ended up being relatively uneven. Just make sure that there are no lifted parts that may touch the PCB, or you could create a short circuit. And of course, remove the parts of copper tape covering the holes for the screws. The procedure to apply the tape on the back panel is basically the same as the one for the PCB shielding. Attach one end of the tape, make sure that it is glued in place, remove another piece of paper from beneath the tape, and attach that too, until the whole piece of tape is firmly glued on the plastic surface. One important thing to do is to make sure that there is an overlap between the tape on the two sides of the case, so a solid ground connection can be established between the two. And of course, cut out all the copper that is covering the holes on the panel. Boring, but necessary. Note that when you will apply the components to the panel, the metallic body of each component will be in firm contact with the copper foil, and so the ground connection will be extended to the whole shield and the components' bodies as well. The copper tape must be removed so to uncover all the holes, but keeping the rest of the back panel protected. At this point, it is possible to start applying the components to the panel. Start applying the potentiometers to the panel, the top row first. The potentiometers need to be applied from the back, then you put on the front sides the washer and then the nut. To tighten the nut on the front side, you can use a wrench or any other tool you like. Just be careful not to touch the panel itself, otherwise you could scratch it. The wrench I am using slides on the exposed part of the washers so it doesn't touch the panel while I tighten the nuts. Once the first row of potentiometer is completed, attach to the panel the potentiometer for the FM depth control, and after that the potentiometer to control the pulse width. Next, install the multi-turn potentiometer for the transpose function. The potentiometer I used comes with a special knob that is able to count how many turns the potentiometer makes. That black ring installed in place of the washer is the one that will hold in place the graduated scale of the knob, which needs to stay put while the knob is rotated. There is in fact a hole in the panel to host a pin that comes out from the bottom of that black ring. That way the ring is not able to rotate. A notch on the disc itself corresponds to a pin on the back of the graduated scale, which will help keep it firmly in place. More on that later. Next, attach the jack sockets to the panel. There are two types of them, one with a switch and one without. The sockets with a switch are those used for the control voltages of the mixer channels. The switches are used to disconnect the potentiometers when the jacks are inserted in the sockets. These are the sole jack sockets with a switch, 5 of them. All the other sockets are without the switch. But of course, if you have all sockets with a switch, you can still use them. However, the switch will be used only for the 5 sockets on the second row from the top of the panel. Now connect the switch used to select between ramp and sawtooth output. The ramp is the one with the voltage increasing slowly and dropping suddenly. The sawtooth is the one with the voltage that increases rapidly and decreases slowly, as described in the front panel graphics associated with the switch. Once done with the switch, install all the remaining jack sockets, those without the switch. Proceed in order from top to bottom, and I also suggest that you mount first those toward the center and then the ones on the sides. That way you will have more space to use the wrench. I know that this is a boring part, but try to pay attention to what you do to avoid scratching the panel while tightening the nuts. Last thing to do is to insert the knobs on the potentiometer shafts. If you use knobs with an index, like I did, make sure you insert them in the right position, so when turning them they will follow the graphics on the panel. That helps also as a reference point when turning the knobs, so you will know how much they are rotated. I used a blue cap for the FM depth control, a red cap for the PWM control, and green caps for the mixer channel controls. In the future I also try to be consistent through the panels of all the modules, so it will be easier to find the correct controls to use when playing the synthesizer. The last knob is the one for the transpose function. Before attaching the knob, turn the potentiometer shaft all the way to the left, and then also make sure that the scale of the knob is set to 0. The knob I have used can just be inserted on the shaft and oriented in such a way that its pin on the bottom coincides with the notch on the black disc. Then you lock it in place with a screw on the side of the knob itself. And here is a view of the completed panel. Let's now take the PCB we assembled in the previous episode and let's mount it in the case of the VCO module. First, we need to install spacers at the 4 corners of the PCB. We need 8 screws for that, 4 on the PCB side and 4 on the back of the PCB support. The spacers I have chosen are made of brass, which will hold the PCB firmly in place. I made sure that there are no tracks on the PCB in proximity of the screw holes, and so there is no chance of short circuits. I suggest you also to use some sort of metallic spacers. Don't use nylon or plastic ones, they are not strong enough for the weight of this PCB. Once the spacers are attached to the PCB, you can insert the PCB in the case and secure the spacers from the opposite side. Make sure that you use screws of an appropriate length. If they are too short, they will not support well the PCB, and if they are too long, you won't be able to insert completely the screws on the spacers. I suggest 10mm spacers and 6mm screws. Since both the PCB and the panel are about 2mm thick, once the screws are tightened at the two ends of the spacer, there will still be a gap in between the ends of about 2mm. Choose a diameter appropriate for the holes in the panel and the PCB. In my case, I created holes that can perfectly fit M3 screws. M3 is a diameter measurement in the European standard. You can find them also in the US, of course. Otherwise, measure the holes and choose the appropriate diameter in the imperial measurement units. At this point, before moving on, we need to check that the components on the panel closer to the PCB don't touch the PCB itself. You may also want to try inserting a jack in the sockets close to the PCB, so to make sure that they don't touch and don't cause any short circuits on the panel. There should be no problems if you are using my PCB in my case, but checking that is always better than discover accidental issues later on, once you power up the circuit. Now it's time to connect all the cables that currently are hanging from the PCB. Start with the coax cables for the 5 outputs on the bottom of the panel. Make sure you double-check that each cable is connected to the right jack socket. The type of signal carried by each cable is printed on the PCB, and you need to connect it to the correct socket based on the label on the front panel. And be careful to connect the ground and the signal correctly. The ground is the shield of the coax cable and goes to the pin of the socket that is connected to the body of the socket itself and the shielding on the panel. The central wire of the coax cable goes instead on the other pin of the socket, the one connected to the longer prong that touches the jack tip when inserted in the socket. The other thing to pay attention to is the soldering iron. There are a lot of wires all around, and you have to prevent the iron from touching the insulation of these wires, or they will melt, causing short circuits. You are going to need a lot of patience to do this whole procedure. Now that the first 5 cables are connected, we can use some zip ties to hold them in place. And this will ensure that at the end of the whole process there is going to be less clutter, and also the cables will not be free to move and break over time. At this point, connect the cables related to the 3 exponential inputs. The procedure is the same. Make sure to attach to the panel the right cables in the right place, following the labels on both the panel and the PCB. If you have done like I did, you will have different colors for the ground and the control voltage, and so it will be even easier to identify where each wire needs to be connected. Proceed the same way with all the other cables, just leave alone those cables for the control of the mixer channels, both the potentiometers and the jack sockets, since those have to be connected in a different way, which we'll explore later. Add zip ties wherever you think it's useful to keep everything rigid in place, while at the same time leaving space around to be able to reach the IC sockets on the PCB, since we have not yet inserted the ICs on them. So at this point there are only 5 cables left, 1 cable for each pair of potentiometer and jack sockets for the mixer channels controls. These are the sockets with a switch, and we have to make the connections in such a way that the potentiometer will provide the control voltage. But whenever a jack is inserted into a socket, the switch embedded in the socket itself will disconnect the potentiometer, leaving only the control voltage from the jack to control the specific channel of the mixer. Let's now take a look at these jack sockets and how they need to be connected to the potentiometers and the cables. Here is a jack socket with a switch, like those 5 already installed in the panel. This socket has 3 different pins to attach wires. The pin on this side is connected to the body of the socket, and so it is the ground connector. That will allow a jack, when inserted, to have its body connected to ground. This other pin, on the opposite side of the long prong, is actually electrically connected to the long prong itself, and that is the pin that will be electrically connected to the tip of the jack when it is inserted in the socket. And then there is this one extra pin, this one on the other side of the first pin we mentioned. This one is electrically connected to this blade that touches the long prong of the socket. The prong and this blade are those that make the switch we have talked about. The switch is normally closed, but when I insert the jack into the socket, the switch opens. So what we will do is to attach the potentiometer to the PCB through this switch, so that it will be excluded when the jack is inserted. And at the same time, when the jack is inserted, the signal going through its tip will replace the signal from the potentiometer. This is the schematic of the connections among the jack socket, potentiometer and the 3 wires cable from the PCB. So this one is of course the potentiometer, and this side of it is connected to pin 1 on the PCB, which is the ground side. This other side instead goes to pin 3 of the PCB, which is the side that goes to the plus 12 volts of the power supply through a 2K resistor. The cursor of the potentiometer is connected to the blade of the jack socket, which, when there is no jack inserted, is connected to the long prong and from there to pin 2, where there is a 100K resistor that goes to one of the mixer control pins of the SSI2130. When the jack is inserted in the socket instead, this switch will open, disconnecting the potentiometer, and at that point the voltage that controls pin 9, 10, 11, 12 or 13 of the SSI2130 will come directly from the tip of the jack rather than the potentiometer cursor. What we will do now is to make some of these connections on the panel itself. We will connect directly the cursor of the potentiometer to the blade of the socket. Then we will connect together the grounds of the potentiometer and the one of the socket. Last, we will connect these 3 wires of each cable to the corresponding places as per the schematic I just described. So, one will go directly on the pin 1 here, another one will go to the pin 3, and the last one on pin 2. Pin 1, 2 and 3 correspond to the same pin numbers of each cable on the PCB. So let's start by connecting a wire that goes from the ground side of the jack to the ground side of the potentiometer. Let's concentrate on these 2 components to see how the connections need to be done. And let's start from the connection between the blade of the jack socket and the cursor of the potentiometer. This is the pin connected to the blade of the switch inside the socket, and here I am soldering the first wire. The other end of the wire goes instead to the cursor of the potentiometer. The second wire will go on the ground side of both socket and potentiometer. This is the pin that corresponds to this side of the potentiometer. I'm starting connecting first the wire to the socket side, and then I solder the other end of the potentiometer. Soldering the wires on the potentiometer side is relatively more difficult because the potentiometers I use do not have holes on the pin when I can lay the wire. More difficult, but not impossible. And now we can connect the cable. With the colors I used, the white wire corresponds to pin 3 in the schematic, the green wire corresponds to pin 2, and the blue wire corresponds to pin 3. At this point, rather than making this a long and boring video, let's conclude with a picture of all the wiring on the back of the panel, which is now completed. Next time, we will start immediately with the tuning of the VCO, its testing, installation in the rack, and final test with an amplifier. See you in the next video, and as usual, happy experiments!